Continuing on where we left off last time, we now want to go to part B. What fraction of students whose GPA in year 1 was 3.0 had a GPA of 3.5 or higher in year 2? So we're going to use this regression line because it's important for this problem, and we can get our prediction, and then we'll use the RMSE to compute the probability that a student scored 3.5 or higher. So if we plug in 2.5 here, sorry, 3.0 here, 3.0 here, we get predicted GPA is 0.8 times 3 plus 0.65. So the predicted Y is 3.05. 3.05. So this is the average. So if a bunch of students who have a GPA of 3.0, then on average we expect their GPA to be around 3.05 in the second year. And this is our best guess if we had to give a single number for what we think the student's GPA will be in the second year if he had a GPA of 3.0 in the first year. So how do we compute the probability that he has bigger than 3.5? Well, what are we asking? So this is our data. This is X. This is Y. This is our line. All right, so we're saying, well, X is 3.0. 3. The predicted Y is, draw it out here, 3.5. So we have a normal curve roughly centered around 3.5 with an SD of the RMSE. So the SD here is going to be the RMSE. So what's the RMSE? The RMSE is square root of 1 minus r squared, and remember r is 0.8, so it's square root of 1 minus 0.8 squared, and that times SDY, so that's times 0.6, and that is equal to 0.36. So now we need to ask how many SDs above 3.05, or rather how many RMSEs, which is the SD in this case, above 3.05 is 3.5. So we can compute our Z value, right, because this follows a normal curve. So Z is equal to 3.5 minus 3.05 divided by 0.36, and that is equal to 1.25. So what are we asking? We're saying, okay, now we have a normal curve with mean 3.05, and let's just look at this side of the normal curve, and we want to say go out to 3.5. So in terms of Z-land, once we convert that to a Z-score, that says, so we're looking at this area over here, that says that I'm going out to 1.25, and I'm looking at this area here. So I looked that up on a table, and that gives, from the table, that gives me about 10.6%. So about 10.6% of students who had a 3.0 GPA in the first year will have a GPA of at least 3.5 in the second year.